Hello guys, for today's lesson, we are going to new chapter, which is chapter 6. Chapter 6 is a periodic table. We are going to cover two main topics, which is classification of elements and another one is periodicity. Okay guys, let's dive into each topics. The element in a periodic table are arranged according to increasing number of proton or atomic number. Besides that, we must know that the position of elements can be determined by using electronic configuration. Now let's take a look at the modern periodic table. Generally, in modern periodic table, we have two common terminology, which is down the group and across the periodic table or across the period. Hello guys. A group is a vertical column of the periodic table. The total 18 groups numbers as 1, 2, 13 to 18. The other 10 groups, which is group 3 to 12, are the transition metals. Elements in the periodic table can be classified into 4 blocks according to their valence electron configuration. These blocks are block S, P, D, and F. A period is the name given to a horizontal row of the periodic table. The periodic table has 7 periods and numbered as 1 to 7. Now, we are going to the next subtopic in chapter 6, which is 6.2 periodicity. There are two factors will affect the atomic radius of an element, which is the effective nuclear charge and the shielding effect. Effective nuclear charge or Z effective is the net positive charge experienced by the valence electron. By using this formula, we can conclude that when Z effective increase, the atomic radius becomes smaller. The shielding effect or the screening effect is caused by the mutual repulsion between electrons of inner shell and the electrons occupying valence shells. Generally, shielding effect is directly proportional with atomic radius. What is electronegativity? Electronegativity is a relative ability of a bonded atom to attract the shared electrons. As we refer to the periodic table, the electronegativity of an element are decreased down the group and increase across the period. What happened to the electronegativity of element across the period 2 and 3? By using the information given below, we can conclude that the electronegativity of elements across period 2 and 3 will increase. Meanwhile, by using the information given, we can conclude that the electronegativity of elements down the group become decreased. Now, let's take a look at the definition of ionization energy. Now, let's take a look at the definition of the first ionization energy and one of the examples.
Hello guys!
Generally, when across the period, the first ionization energy will increase. Meanwhile, when down the group, the first ionization energy will decrease. Now, look at the information given. This is the reason why the first ionization energy will increase across the period 2 and period 3. The first ionization energy down the group become decreased. This is because when down the group, the number of shell increase. The shielding effect also increase. So, the attraction between valence electron and nucleus become weaker. Generally, we know that across the period, the first ionization energy will increase. However, there are special cases against these general rules. For example, between boron and beryllium. To understand this phenomenon, we must know the concept of half-fill configuration. Check out the link given below to study more about irregularity of first ionization energy, or you can refer your lecture notes.